Thank you so much. So I'm Angie Jones. I'm an automation architect and senior developer advocate at Applitools. I blog about test automation strategies and techniques at angiejones.tech. And you can find me on Twitter at techgirl1908. Today I'm going to share with you a story of the build that cried broken. This is a typical diagram of a CI process. And all of these parts need to work in perfect harmony for this to be effective. However, there's one piece here that's known to be very volatile. Which piece is this? The test, of course, the test. So that's what we're going to focus on today. And fortunately for us, there's an ancient Greek storyteller by the name of Aesop, who knew about CI 2,000 years ago. And he left us with some fables. So I'm going to share with you some of the morals of those fables and how we apply it to CI. The shepherd boy and the wolf, also known as the boy who cried wolf. You've probably heard this one. There was a young shepherd boy, and he was responsible for taking care of the village's sheep. Now this guy, he was a prankster. He was a young kid. And so sometimes he would yell out, "Wolf, wolf," and all the village people would run over in a state of panic, only to find him laid out laughing at their expense. So they fell for this maybe 3 or 4 times, and then eventually they wised up. And they began to ignore him. However, one day, a wolf really was coming. And the boy cried, "Wolf, wolf," and no one came. And of course, the sheep perished. This used to be my life. So I worked on a team where we had 4,000 tests running as part of CI. And these tests started failing, and the developers would run over in a state of panic, thinking that their check-in broke the build, only to find that those tests were just like the shepherd boy, crying, "Broken, broken," and nothing was really wrong. They fell for this several times, and eventually they began to ignore the tests. Now one day, there was the product owner on the team who needed to demo this product, our product, to a potential client. And they went to demo scenarios that they've demoed dozens of times before, and one of the scenarios didn't work. It was broken. They were mortified and later went to our manager and asked, "What's up with this? Don't we have tests around this scenario?" Because this is one of the demo scenarios. And our manager said, "Yeah, I think so. Let me check." He asked us about it. We checked the bill. Sure enough, there was a test for that scenario that was red. It'd been breaking. But because we were no longer paying attention, we'd lost trust in our build. That went undetected. So my manager realized we can no longer live like this. We have to get our acts together. And I'll share with you the story of how we did that. The fox and the goat. So there was a fox who was walking down a trail one day, and he was pretty parched. He saw a well of water, so he jumped in and began to drink the water. Once he quenched his thirst, he tried to get out of the well, but he couldn't. He was too deep in. He tried and he tried to climb to no avail. So he ended up having to spend the night in this well. Now the goat came along the next morning, walking down this same trail. And the goat heard a noise from the well, so he looked inside. "Hey, Mr. Fox, what are you doing inside of that well?" Mr. Fox said, "Oh, I'm drinking this water. It's so delicious. You should come in." So the goat jumps in. The goat jumps in, the fox jumps on the goat's back, and then leaps outside of the well and leaves the goat there stuck. And then the fox looks down and says, hey, you should look before you leap. Now for us, we didn't look before we leaped. We knew that we wanted to do continuous integration. And everyone told us in order to do continuous integration, you have to automate your tests. We said, okay. And we went with this. And we got so caught up in automating the tests that we lost sight of what our end goal was. Our end goal was for fast feedback in the continuous integration cycle. And yet, all we cared about was automating. So much so, we began automating in sprints. All of our acceptance tests must be automated. Automate all the things. And we were no longer focused on what it is that we were supposed to be doing, which got us in trouble. The lioness and the vixen. So these are two mothers that went out one beautiful spring day with their children. And like mothers do, they began to brag on their kids. So the lioness said how strong her cub is, how beautiful his mane is. And the vixen began to say how quick and witty her kids were. And this became competitive after a few exchanges. And the vixen then wanted to one-up the lion. So she says to her, yeah, well, you know, I have a whole litter. You only have that one cub. And the lion looked. She held her head up high, and she said, yes, I only have the one, but he's a lion. The moral of this story is quality over quantity. So, like I said, we had 4,000 tests. We were automating all of the things, and this really got us into a pickle. The tests that we were automating, we didn't care if these were valuable tests or not. These were acceptance tests. Of course they're valuable. But what we began to learn is that they're valuable in the context of that sprint, not necessarily for long term. So as we're adding and adding to our backlog of tests that are running, we're making our CI process longer to run. Sure, we can split these up and run them in parallel, but still, it's a lot to maintain, a lot of noise that's coming in. How many times have you checked something in and there were 50 tests that failed? And you thought, oh my God, what did I break? This was just such a simple check-in. And you look at those 50 things and they're all the same, right? Same failure, yet different tests. A lot of times we're automating the same steps over and over again. The scenarios may vary ever so slightly, but the same things are running. This adds a lot of noise to your CI pipeline. So we learned to trim a lot of that and evaluate what it is that we were automating and pick the right scenarios to automate, the ones that were of high value, the ones that, yes, we want this to block our integration if this fails, right? If it's something that if it failed, you wouldn't care, you'd open a bug and no one would ever fix it, that might not be a good candidate to add to your pipeline. Now, in addition to making sure that we were automating quality scenarios, we also needed to develop those scenarios with quality. Flaky test, the death of a CI process. A flaky test is one that fails sometimes and passes sometimes on the same code base. You don't know what you're going to get with this test. And there's several reasons why this might happen, especially with your front-end tests. So a lot of times people will say, oh, make sure your tests aren't flaky, but not give any guidance on how you do this. So I'm going to share some of the steps that we took to remove the flakiness from our test. For one, we made sure that we had stable identifiers. These were for the UI test. So all of the fault wasn't on the test themselves. Some of the fault was on the application because it lacked test automatability, meaning there weren't proper hooks or IDs available to be able to automate this in an effective and efficient way. When you are introducing new elements on your UI, it's a very good practice to make sure you're including IDs. And so we had to get our developers in this habit. Otherwise, when we wrote the test, we were relying on things like the class, which is supposed to be used for styling, right? Or an XPath or something like this. And those are quite brittle and they can change. So having our developers put in IDs was extremely helpful. Also, scripts run a lot faster than humans do. And as we're working on an app from a customer perspective, you click a button, you don't really notice the slight latency there, but your scripts do. And so we had a lot of scripts that were failing due to timing issues. It was ready to move on to the next step, yet the application wasn't there yet. And so we put things in like hard-coded waits and sleeps on the thread, which proved to be problematic as well. So again, going back to what is our end goal is fast feedback. So slowing down our scripts more than needs to be was problematic, right? For example, let's say you have a script that needs to run on 3 different environments. On one of them, a certain action looks like it takes about 1 second. Well, if that action takes 1.1 seconds, then it fails. So you say, okay, I'll increase this to 2. You do that on the very slow machine. It takes 2.2 seconds. Oh, God, okay, I'll increase this to 5. So you're constantly chasing this. You've added 5 whole seconds, the greatest common denominator, to this, when in some cases it only takes 1 second. Well, that's 4 extra seconds that you're waiting. Doesn't sound like a lot in one test, but when you have 4,000 of these tests, that can quickly add up and go against what our end goal was. So that was something else we looked at. A lot of the APIs that are available for test automation provide more sophisticated ways to wait, such as waiting for some condition to be met. Okay, so we're waiting for this page to load or this element to appear before moving on. That way, the scripts only wait as long as they need to. Test data is also a big culprit in flaky tests. So the data that you're using for your tests, a lot of times this is shared data across multiple tests. Some tests are manipulating this data, removing it, adding it, all of these things. And so it's really unreliable to rely on the data that's there. But you can do this in a better way. What we did was to consult a source of truth as opposed to hard coding what we expected it to be, right? For example, let's say that we had a test that was searching some movie database for Avengers, right? So we wrote this script back in 2015, I think. And let's say there was 2 results that came back at that point. So we hard-coded the number 2, expect 2 results. Well, in 2018, that test would now start failing because there's another movie. We fixed that, added to 3. Now this year, yet another movie, Avengers movie, has come out, and we're back to fixing up that test. So as opposed to hard-coding that number, we began to consult an API, a database, whatever we consider the source of truth, get the number or data from there, and then compare what's being shown to the user to that source. And then finally, this was golden, using shortcuts in our application. So UI tests by default are pretty slow. They're the slowest kind of tests you can write. But there's a lot of shortcuts that you can take if you utilize your application in the seams, the code seams, S-E-A-M-S, that are available. For example, let's say you had a scenario that you wanted to automate to remove an item from a cart. Well, to do this scenario, you got to do a lot of prereq stuff. So the script would say, let's search for the item. Let's get the results back. Traverse through those results until we find the item. Click on it. Then there's an add to cart button. We're going to click on that add to cart button. And then we go click the cart icon. And then we go over to the cart. And now finally, we can begin what it is that we wanted to test. This sounds like something that you have to do, but when you really think about this, it's problematic in multiple ways. One, it's slow. And again, our end goal is fast feedback, so slow tests are not really helpful. And also, it's fragile. So navigating through the UI in that way, this can easily break. You're adding all kind of conditional waits and things in here to try to make it work, but it could be problematic and break before you ever get to what it is you're wanting to test. Also, it's dependent on other functionality, right? So back to what I was saying about the noise of tests and lots of them failing for an unrelated check-in, right? So if I were running this cart scenario and search was broken, then I have a failed test saying that removing an item from a cart is broken. And I'm in a state of panic, and I go and look and see, oh no, it's search that's broken. Still bad, but not as bad as the cart not working, right? So you don't want to be in this kind of state where some other unrelated feature is blocked because of a test. So what we did was, again, use the code seams in our application. Instead of doing all of this stuff through the UI, let's bypass all of that. We can call an API to add the item to the cart, and then just go directly to the cart page to begin our test. Much simpler, much faster, and it's not dependent on other functionality in the app. Storytime. The astrologer. So there was this astrologer, a really deep guy. He would only come out at night when the stars were in the sky. And he would walk along the street just kind of gazing into the stars. And they would speak to him and tell him visions of the future. His neighbors would try to say hello. He didn't hear them. He was so focused on these stars. Well, one night, as he was walking and gazing into the sky, he tripped and fell inside of this giant black hole that was in front of him. Moral of the story, meaning to look at what's in front of you and don't be so focused on the future, which is definitely where we were. So we had stopped paying attention to our tests. We weren't utilizing the information that it was telling to us. We weren't observing any patterns because we were so focused on new feature development. We'd become to value new code over working code, which is a dangerous place to be in. So we decided, okay, we have to have someone monitor these builds. Our builds are in a very bad shape. We had hundreds of tests that were failing, not one or two. And so we decided that we would create 2 tasks for every sprint that was just to monitor the builds. 1 task per week in a 2-week sprint. And one person would be assigned to this, and this was pretty much their job for that week. So they're not writing new feature development or new automated tests. Your role is to focus on the build and try to gather any information that it's telling us and triage the failures and yada, yada. Now, this might not be something that we would have gotten buy-in from our managers for, except we had that horrible case where the demo failed, and so our manager was determined to get us in a good shape. Now, this isn't a fun thing to do. Nobody wants to be on the duty to monitor the bills, right? But like I said, we were in really bad shape, so this was necessary. Now, monitoring these bills, you have 200 tests that fail on a given run. You don't know where to begin, where to start looking, right? So this was taking a lot of time, a lot of trial and error. So we decided to just create a database, very simple one-table database, where each test would report its results into this table. So the columns were timestamp, test ID, the functional area, the result being pass or fail, and the build number. Given this information, we could then monitor those results a lot better. So instead of just randomly picking a test, a broken test to look at, we could then start doing more wiser choices, such as show me all the tests that have failed for the very first time. This is a good indicator that this might be a bug. Or show me all of the tests that are failing and they're in the functional area of the shopping cart. So this is our money maker. This is where we want to spend our time. So this became really, really helpful in cutting down the monitoring time. The farmer and the stork. So the farmer, he began to plant his harvest. He put down some seeds, and there were these crane birds that would come and dig up the seeds and eat them. And this happened several times. And the farmer got pretty upset about this, and he decided, you know what? I have something for those birds the next time they come. Well, one day the crane birds, they were on their way to the farm, and there was a stork that saw them and asked, hey, where are you guys going? And those crane birds said, oh, we're going to get something to eat. Well, everybody likes free food, so of course the stork went along. When they got to the farm, the stork, he observed the way the birds were eating and kind of looking to their right and left as if they were sneaking, and he realized something's not quite right here. So the stork did not partake in this. However, remember, the farmer had left a little surprise for them, which was a net that cast all the birds. And the farmer came over, aha, I caught you thieving rascals. And the stork pleaded, oh, wait, please, please. It wasn't me. I didn't partake. And the stork says, birds of a feather flock together. Or in other words, one bad apple spoils the bunch. Now, we had our monitoring database helping us. We were shortening the time it took to triage the failures. We were actually fixing the tests, and we were making a dent in this disaster that we had. And so we would go to stand-ups and feel really proud, like, oh, we got it down from 150 failures to 140 yesterday. And no one applauded, no one cared. No one was excited about this. Why? Because there's still 140 tests failing. The build is still red. Even if there's one of these tests failing, the build overall is red. So we realized, okay, it's going to be a long time before we get to where we need to be, and we can't keep living in this filth. So we decided to do something different. We split our bucket into two buckets. One bucket, the green one, held the tests that were reliable, the ones that we could trust. And we had data to back this up from our database, right? So all of those tests, we kept them in the main build and said, okay, developers, here's the build that we now can trust. Go forth. And then all of those bad, flaky, unreliable, or failed tests, we would move into this red bucket, a different build. Now this bucket we still let run, and we still kept it in view, just separate from the main build. We didn't want to hide this away and work on it because this is still technical debt that everyone needs to be aware of. We don't want you to think that life is peachy because you have your green build. And it was very simple to do this. We used TestNG, which has groups annotation attribute. And so we just put a little name on this group called unstable. And in our main build, we would just say run all the tests except the unstable one. So it's really easy to move this out. And for every test that we moved out, we added a ticket to JIRA for it. Again, the visibility. We want you to see this. And we wanted our product owner to prioritize this with the feature work. Because remember, we're no longer valuing new code over working code. This stuff has to work collectively. And so our product owner would look through the backlog and manage this along with the new feature work. And if she'd see something that was a very high priority, like some cart tests are failing, then she would gladly want to move those into the next sprint for people to work on. Now, with these buckets, we had some rules. We could not have more than 1.5% of the overall bucket be in that red bucket. And we felt good about this because Google's allowance is 3%. So we were half of that. Now, if it got past 1.5%, that's 60 tests of 4,000. If it got past that, needed to be all hands on deck. Let's stop feature development and let's get this number down to something we're comfortable with. As we were going through these tickets and fixing the tests, this was also a wonderful opportunity to delete some tests. Remember, we got really carried away in automating all of the acceptance tests. And so now we see a test failing, we think about it and say, is this test really of value to us? If not, delete. And that's a really fun thing to do. Also, there was times where the test, you were patching and patching, and sometimes it might be better to just delete that whole thing and start over. So all of the ones we weren't able to totally get rid of. But there was a case once where this test, I spent an hour on trying to fix this test. I'm patching it and patching it. It's spaghetti code written by someone else. I don't understand why they made the choices that they made. And so I'm trying to figure it out and fix it up. And I remember hearing a talk by a professor. His name was Atif Miman from the University of Maryland, where Dr. Miman, he took a summer to go and work at Google, and his assignment was to research the Flaky test. And because he's from academia, he came up with all of these amazing statistics and things around it. One of them that stood out to me was that if a test has been modified more than 3 times, then the chance of that test becoming flaky increases exponentially. So as I'm patching this hell of a test, I'm thinking about Dr. Meme and I'm saying, I bet I'm the fourth one to go and mess with this test. And so I decided to go find the feature, go find the test spec, and read what it was that we were testing and how to accomplish this. Got it, deleted that test, rewrote it. It took me 25 minutes to rewrite this test, where it took me an hour to try to patch it up, and I still wasn't even successful with the patch. And it went from 113 lines of code to 38 lines of code. So much cleaner tests. So this is also a possibility. The last story, the dog and the hare. So a dog and a hare, they were out on a field one day, and the dog says to the hare, I bet I'm faster than you. And the hare says, no way. And they said, well, let's settle this with a race. Agreed. So they begin to race, and the hare is in the lead. So the dog gives it all of his might, and he finally catches up to the hare, but he's not able to surpass him. So he gets really angry about it, and he tackles him and gives him a little bite. The hare's like, dude, what's wrong with you? What's your problem? Why are you biting on me? Oh, I'm sorry, my bad, my bad. I got carried away. Please forgive me. Hare says, okay. Dog says, can we try again? Sure. So they race again. Again, the hare is in the lead. The dog catches up to him, but he doesn't pass him, and the hare wins the race. Dog says, that was great. Can we go again? The hare says, sure. So they do it a third time, and of course the hare is in the lead. The dog catches up to him, again tackles the hare. The hare says, you know what? I'm done with you. I don't know if I can trust you. I don't know if you are friend or if you are foe. Now, we gotten our bills into a pretty nice shape. We had the main bill. We were gaining the team's trust again. But as we were fixing up those tests from the red ones, we would add them back in because they're green now. But sometimes they weren't. They were still flaky. And remember, flaky tests sometimes pass, sometimes fail. And so we were prematurely adding some of those back in, and the developers were getting pretty pissed about it. And so we were going through this cycle of them trusting the test and then not trusting the test and then trusting the test. And we realized, okay, we can't get back to where we were before. So we made an agreement. You only put the test in this green bucket if you are 1,000% sure that is actually fixed. If you're not quite sure, you think it might be fixed, then just keep it over here and let it run. Remember, this red bill was running anyway all the time. So let this run maybe 10 times. Make sure that it's green every single time before moving it back in. And that helped quite a bit. So how does this story end? We now had less than the 4,000 automated tests because we got to delete those low-value, low-quality tests. We had less than the 1.5% unstable. Our main bills were always green unless there was a change in the app, meaning it actually is a real failure or the developer changed the behavior of the app in some way that the tests need to be updated as well. And they were cool with that. And then everyone trusted the bill for feedback. So nice, happy ending.